All right, well, hello everyone. Thank you for joining us today. Our project is the Southwest Maquoketa Land Use Plan for the City of Maquoketa. My name is Nick Radcliffe. I'm the project manager for the semester.
I'm Thomas Daw.
Matthew Hinker.
Shane Hostetler.
And together we make the DRHH project team. We are students at the University of Iowa, all seniors graduating with a degree in civil engineering. For today's presentation, we're going to start off by talking a little bit about what the project entails, and then we're going to move into the design elements of the project, how we made some of those designs, and then finally we're going to talk about the benefits to the city, so the increased tax base and then also the infrastructure value that's added. So the land use plan is for the south side of Maquoketa, and it entails a street layout, a trail layout, as well as a sanitary sewer layout, a water main layout, and then also stormwater management.
So this is our proposed zoning plan for the area. It consists mainly of single-family residential housing. This will add 490 new single-family homes to the area, averaging lot sizes are 0.3 acres. In addition to the single-family residential, we are providing some multifamily and commercial space. And we strategically placed the commercial space to the southeast over here, which is going to be an extension of the existing commercial area there to the west of South Main Street. And we felt this was a good location because it will have minimal impact on existing residents as well as the new residents in the area. So the proposed street network for the area was influenced mainly by the existing streets to the north as well as the lay of the land of how it exists currently. So we ended up trying to extend that gridded network that Maquoketa currently has. However, with the lay of the land, we ended up having to modify that so that way we could use the land how it is without moving large amounts of material. So our street network is made up of 3 main streets, which is arterial, collector, and local roads. Our arterial street is connecting into West Farmland Drive as well to the north and Carlisle Street to the south. These connections were determined to be the best because they will limit the amount of traffic on existing local roads and not impact existing residents. There is one residential house that will be mainly impacted on the north west side at the connection to West Farmland Drive. However, in the southeast connection, it will only increase traffic along the existing commercial areas. Off of our arterial street, we have collector roads to help funnel the local traffic to the arterial street to keep new residents off of the existing residential streets just to not impact the existing area too much. And we have the collector roads surrounding the proposed commercial area to provide adequate space and capacity for the large amounts of commercial vehicles. So our arterial street we have 2 main layouts that we're planning to see along the area, differing between the commercial area and the residential area. So along the entire length of the arterial street, we propose and recommend that there's a through lane in each direction and bike lanes on each side of the street. In the commercial area, we recommend that a 2-way left turn lane will be provided in the center to provide safety for the large amounts of vehicles turning in that area. However, when we get into the residential area, we recommend that goes away to provide room for parking on both sides of the street. And then for our collector streets and local streets, these do end up getting a little smaller. However, in the collector street, we recommend a through lane in each direction and parking on one side. And then when we get down to local streets, we recommend allowing parking on both sides of the street. However, there will be a shared use through lane, so there won't be a designated lane in each direction in both ways. And this helps minimize the width of the roadway in that area, as well as discourage people who don't need to be in the area from using those streets. Some common elements for all of our streets are 4-foot sidewalks, which are standard in the city of Maquoketa, so we recommend that we continue that. A 10-foot utility easement outside of the city's right-of-way, which is again standard in the city of Maquoketa, so we recommend that we continue using that just to keep it uniform, as well as adequate space from back of curb to the sidewalk. And this allows for trees to be planted along all of the roadways, as well as adequate snow storage, which basically just means that there's room for snow from the road to be placed there, so that way it's not getting pushed from the road onto the sidewalks and being a nuisance for the residents. For pavement, we have two main pavement designs, one for the arterial road and then one that will work well for the local and collector roads. We recommend for the local and collector roads to have 3 inches of hot mix asphalt on top of 10 inches of aggregate base, which this is what the city of Maquoketa is currently using, and we feel that it is sufficient for the community needs and has worked well so far, so we think that will be a good continuation. However, for the arterial road, we do recommend that Portland cement concrete be used, 9 inches of this on top of 6 inches of base, and we determined this by estimating traffic demand from the increase of the area and using the statewide urban design and specifications manual to design that pavement.
The next aspect of the plan consisted of a stormwater management. To start off, drainage areas were delineated based on existing ground as well as the proposed street network layout. The drainage areas are shown in the map on the right in the light blue with culverts in yellow. So a drainage area was created for each culvert. Undeveloped areas west of the highway that still drain through our site were forecasted to future conditions based off of the city's comprehensive plan. Rainfall data and soil information was also gathered, and all of this information was used to determine flow rates that were used to then design the 19 culvert structures throughout the development. These culverts were a mixture of box, double box, and circular culverts. Embankment heights over the culverts and channel depths were also determined with freeboard space of 1 foot or space between the water level during the maximum flood and the top of the embankment or the channel. Low openings of houses just upstream from culverts are also specified as 1 foot above the embankment height to provide additional protection against flooding because culverts tend to back water up behind them. The city of Maquoketa requires stormwater detention for any new development in the city. So we were informed that the IODNR is looking at multiple project sites throughout the city of Maquoketa for water quality projects, and one of those is outlined in red in the northeast corner of our development site on the map. It's there that we are proposing a regional stormwater management option where all of the drainage area will drain to that site rather than having multiple stormwater detention sites throughout the area. Storage was calculated based off, or the required storage was calculated based off of the difference in runoff from the existing ground, which consisted of mainly farm field, to the proposed condition. As development increases, so does impervious area and therefore runoff, and this runoff needs to be stored and released at a controlled rate. So this storage required that was calculated is about 9.5 acre feet, and the DNR site is about 20 acres in area, so this is plenty of room to store that amount of water. The allowable release rate was calculated to be about 650 cubic feet per second, while the inflow was about 2,250 cubic feet per second. A bridge was determined to be needed connecting our arterial to the West Carlisle Street on the east side of Prairie Creek, and is shown in red on the FEMA floodplain map in the bottom left corner. As Matthew mentioned earlier, this was a good spot for the bridge due to the connectivity it provides for the proposed commercial area to the existing commercial on the east side of Prairie Creek along Main Street. Another benefit to this location is that it occurs at an area with a narrower section of floodplain. So this will minimize the impact to the hydraulics compared to if it were located on a wider floodplain area. The bridge will be a triple span concrete deck bridge with 2 piers and vertical abutments that will allow for minimizing the span length. The deck will be a continuation of the lane configuration of the commercial area, and will have with bike lanes and snow storage, and will also contain sidewalks on both sides with a traffic barrier. Inspiration for this bridge came from an existing bridge in Dubuque. This bridge will act as sort of a gateway into the community and will provide a prominent feature for the community to be proud of through aesthetic features such as an ornate railing as well as a brick facade. These features can also be continued throughout the community on things like the head walls of the culverts and railings on embankments to provide a sense of continuity and a sense of place in the community.
In terms of the water main should be located either on the southeast or southwest side of the road, 1 foot inward from the back of curve, so it will be slightly underneath the road, with the arterial main running along the arterial road. In terms of hydrants, there should be one placed at each intersection, about within 25 feet. And then they should also be spaced in the single-family areas, 400 feet apart. And then in the commercial and multifamily areas should be about 300 feet apart. And they should be placed at high points whenever possible. That way they can act as air relief valves, since air will naturally get into the water main system and needs to be removed. In terms of valves, there should be 3 placed at each 4-way intersection and 2 placed at each T intersection. And in addition to those valves, they should also be placed 800 feet apart in the single-family area, and then 400 feet apart in the multi and commercial area. The purpose of these valves is mostly in case there's a water main break, you can isolate that section of pipe and replace it as needed. Basically, the more valves you have, the less area that would be affected by a water main break. And then in terms of materials, the arterial should be at least 12 inches in diameter, with the distribution mains being at least 8 inches in diameter, and the pipe should be made of PVC.
Similar to the water main design, the sanitary sewer design was dependent on Maquoketa's existing utilities. Thankfully, Maquoketa has planned ahead to some degree of, they have put that red line that runs along the center of our site right there as an existing sanitary sewer line, and we did calculate that is an adequate design to supply our site with enough sewage space. So that's great news. Ultimately, our design was dependent on that, and thankfully that is in a great location. So after we determined that that line was feasible, we were then able to design the rest of the water or the sanitary sewer lines. 8 inches was an adequate size for all of those pipes. However, we did propose putting a 10-inch pipe in 3 locations. They're shown in blue there on the screen. The reason for these 3 lines, the one on the far east side to the right of the screen, is for any unforeseen water usages there, any unforeseen sewage discharges that maybe there's a business that has a lot of waste that they're producing or something like that. Ultimately, we don't foresee that happening, but just in case. Then on the west side, there's those 2 other blue lines, and those are to provide extra space just in case the development to the west of US Highway 61 is very large or something like that. Then moving into the trail design, we were able to design a trail based on the city's request for a bicycle and pedestrian multi-use trail. And so this trail is going to be 10 feet wide. It's going to have a depth of 5 inches of concrete, Portland cement concrete, except for the dash portion, which runs along the main drainage way there. That dash portion is going to have a depth of 7 inches, and the reason for that is that the city has sanitary sewer manholes running along there, and so we wanted to provide their service vehicles access to those manholes right there. Additionally, at the top of the screen, there's a red line on the high school property. Our trail connects into that simply, our trail ends on our site. We have proposed that the school in the future may put in a trail there to connect to our trail system, just to provide interconnectivity among the different neighborhoods, schools, whatever. And then we've also, after the trail passes under the bridge on the far right side of the map there, it then has a stub going into the DNR site. Our goal there was to provide the opportunity for the DNR to make a trail fit into their water design in some way. Along the south side of the trail, there's going to be trees that we have proposed, and these trees will run along the highway, or the portion of the trail that runs along the highway. And the goal of this is to provide privacy to the residents of the site, both visible and audible privacy from road noise. These trees will consist of firs and pines, as well as some maples and oaks. The firs and pines keep their needles obviously all year, so that'll provide privacy year round. But then we wanted to add some color and some aesthetics with the oaks and the maples. These trees will be planted 20 feet off from the edge of the trail, and the goal of that is to prevent roots from growing under the trail, but then also for trees to have adequate space to grow, I guess.
In terms of the tax base, based off the current properties in Maquoketa, we currently estimate the tax base should increase by about $134.2 million. And then the total value of this infrastructure to the city itself, we currently estimate to be about $20.9 million, while the total actual cost to develop it should be about $27.8 million, but most of that cost is typically paid for by developers.
Ultimately, we are pretty excited, and this was a fun project to do throughout the semester. Frank and the city have been great clients to work with throughout. Ultimately, this is hopefully going to be a highly desirable neighborhood to live in, that people would come from far and wide to live in Maquoketa, and hopefully it's a beneficial thing for you guys' economy as well. Thank you. Any questions?